And I'm going to start by reviewing the three last topics that we covered when we were in this course. If you look at the practice final, you'll see that those three examples, those three topics are covered more thoroughly than the topics from the beginning of the term. That doesn't mean you don't need to know the topics from the beginning of the term, but these are the new topics I felt that, as I looked at the exams, I felt that warranted review. Don't forget, again, if you haven't done that practice midterm as yet, do it now. If you feel you'd like to do it another time and you'd like another chance at it, just email me and I can reset it so you can take it another time. I left it as being able to be only done once because I wanted the experience to be as close to the experience of what you'd have when you take your final. Again, they're not going to be 40 questions on the final, they're going to be 30 questions. Okay, so let's first start with the topic of conic sections. I'll do a very brief review of it and then we'll do a couple of questions. There were 4 types of conic sections that we talked about: the circle, the parabola, the ellipse, and the hyperbola. The circle, you had to be able to find the center and radius of the circle. With the ellipse and the hyperbola, you have to be able to put the equation in standard format so you can find where it crosses the x and y axis and be able to sketch the curve. And basically with the parabola, you have to be able to find its vertex. Sometimes they also ask what are the x and y intercepts, but the more important thing is being able to find the vertex. So we're going to go through a question of these types for each example. I will be attaching to your Blackboard account a review sheet, which is just a study guide for all the important formulas and things that you might come across in Math 136. So you can be on the lookout for that as well. So let's look at, I'm going to write down 3 questions. Well, actually, I'm going to put down 4 questions on conic sections. I'm going to stop. I'm going to start taking attendance at that point. And while I'm taking attendance, you can be working on these problems. So problem number 1 is find the center and radius of the circle, whose equation is x squared plus y squared plus 6x minus 4y minus 3 equals 0. So that's question number 1. This is an equation of a circle. By the way, I'll remind you, I can tell it's a circle because I have an x squared plus y squared term. The x squared and the y squared term are both positive, and they both have a coefficient of 1. If they had any other coefficients, if there would be a 2x squared here, this would have had to be a 2y squared. The x squared and the y squared terms have to have the same coefficients. Usually the coefficient is just 1. In other words, it's just a plain x squared plus a y squared. Second question I'd like you to do is to find the vertex of the parabola y equals 2x squared minus 8x minus 4. Let me rewrite this. Remember, the parabola is the only conic section whose equation has an x squared, but it doesn't have a y squared. It just has a y. Notice there's an x squared and an x term. They don't have to have the x term. You do have to have the x squared, but you don't have a y squared. That's how you know it's a parabola, that U shape. Okay, question number 3 is to do a sketch of each of one of these. So we're sketching 4x squared plus 16y squared minus 64 equals 0. That's number 3. And number 4, we're also doing a sketch of, it's 4x squared minus 9y squared equals 36. And before we go any further, let's just talk about what kind of shape this would be and what kind of shape this would be. Notice both of these equations have x squared and y squared term. But here the x squared term is positive. Both the x squared and the y squared are positive. Here the x squared is positive, but the y squared term has a minus sign in front of it. This means this one is a hyperbola. Because of that minus sign. When your x squared and y squared term have one positive and one negative, doesn't matter what numbers are there in front. If there would have been a minus here, and it could be the x squared that's positive and the y squared that's negative, as in this case, or sometimes it's just the opposite. First you have a not y squared term minus x squared. That will always give you a hyperbola. Remember, the shape is 2 separate branches, 2 back-to-back U shapes. This one has an x squared and a y squared term, but they're both positive, but the numbers in front of them, their coefficients are not the same. That makes this an ellipse. Okay, so now I'm going to give you a few minutes while I take attendance for you to try these 4 problems. I don't know if you'll finish all 4, but we will go through these after I take attendance. All right. First of all, this first one, where you're asked to find the center and radius of the circle. What you have to do is put all the x terms together, all the y terms together, all the other numbers on the other side of the equation. And then you have to complete the square so that you can put this in what we call standard form. So I'm going to do x squared plus 6x and leave a space. Then I'm going to do the y terms plus y squared minus 4y and leave a space. This 3 I'm going to bring to the other side of the equation because I only want the variables on this side. And then, if you recall, what we do is we divide the number in front of the x by 2. Now, just as a reminder, if there would have been no x term, if there was just the x squared and no x term, you wouldn't have to do anything. You just leave it alone, and you would know that that variable, the center for that variable for the x would have been 0. But there is a number here. This is, half of this is 3x. What we do with that number is we multiply it by itself. I'm sorry, it's not put 3x. It's just, you just take half of the number. So half of 6 is 3. 3 squared is 9. I'm going to have to add 9 to complete the square on the x squared plus 6x part. So that x squared plus 6x plus 9 turns out to be the binomial x plus 3 squared. Notice, since I added 9 over here, I better add 9 over here as well, because I've got to keep my equation balanced. I now go to the y, and I do the same thing. I take half of the number in front of the y. So this is a -4. It's going to become a -2. And again, I multiply by itself. -2 times -2 is +4. So I put a +4 right next to the y's, which makes this y minus 2 squared. But since I added 4 over here, I've got to add 4 on this side as well. So let's see what we have. First of all, there's a plus between these two. And what this all adds up to, 3 plus 9 is 12 plus 4, that gives me a total of 16. And now this is in standard form. And it's in standard form, we can right away write its center. Remember, the center is the number that comes from the numbers that are inside the parentheses. The x of the center will be -3, because you always switch the sign. Again, if it would just have been a plain x squared, we would have put the number 0 here. The y of the center, the y coordinate, is +2, because this is a -2. Again, we switched the sign. Again, if this would have been just a plain y squared, we would have put a 0 here. And the radius is the square root of this number. Square root of 16 is 4. That's where they can catch you a lot. Well, you'll look so much to get the right center, and then they'll give you one choice being 16 and one choice being 4, and you might automatically pick 4. Remember, the radius is always the square root of the number that turns out to be on the other side of the equation. So that's how you would do this problem, where you find the center and radius of the circle. Okay. Let's go now to this next one, where it's asking us to find the vertex of this parabola. Now, the formula for finding the vertex of the parabola is x equals -b over 2a. Now, that's really not the vertex. That's just the x value of the vertex. The vertex is a point you have to do both the x and the y values. But once you have the x values, you can just stick it into your equation and it will give you the y value. In this case, my a happens to be 2, my b happens to be -8, and my c happens to be -4. By the way, since I see that the A is positive, remember, when a positive A, it looks like a smile. So this is an opening up parabola. It's an opening up U. And since the A is 2 rather than usually it's just plain 1, it's narrower than the regular parabola is. So figuring the vertex, I do -b. So it's -8, because the b is -8. Over 2 times 2, and that gives me negative and negative, gives me +8 over 4, which is 2. So the x of the vertex is 2. To find the y of the vertex, I simply substitute 4x2 into the original equation. So this is going to become 2 times 2 squared. And of course, you can just do this with your calculator if you want. But don't forget your parentheses. 2 times 2 squared minus 8 times 2 minus 4. Now, remember when you're doing the first do the exponents, 2 squared is 4, 4 times 2 is 8, minus 16 minus 4. So this is 8 minus 16 is negative 8, and negative 4 is negative 12. So the vertex turns out to be the point 2, negative 12. If you wanted to graph it, you would draw that point to go to that point 2, negative 12, and then have your vertex, your parabola opening up. In other words, something that might look like this. Here's 2. Negative 12 is probably all the way down here. And you have something that looks like this. Not a very good picture of it. It should be the same shape on both sides, but it's a narrow U with a vertex at 2, negative 12. Okay, so that's the question about the parabola. Mind you, if they would have asked you what are the intercepts, you find the x-intercept by putting y to 0. You find the y-intercept by putting x equal to 0. Okay, now I'm going to erase, well, let me work on this one and then I'll erase some of this stuff over here because I'll probably need the board. Okay, we said that this one is going to be an ellipse because we have an x squared plus a y squared term. We want to put this into standard form, which means we have to bring the 64 to the other side, which will give me 4x squared plus 16y squared equals 64. And then in the standard form, you have to have a 1 on this side. You're going to divide everything by 64. The ellipse and the hyperbola are put in the same format for standard form. You want to get it equal to 1. So I'm dividing by 64 here, so I've got to divide this by 64 and this by 64. So I divide everything by 64 and reduce. So the 4 goes into the 64, and that gives me x squared over 16. The 16 into the 64 reduces to y squared over 4. And the 64 over 64 just gives me 1. That is the standard format of an ellipse. X squared over a squared plus y squared over b squared equals 1. Remember, this plus is very important. Now, in our case, the a squared is 16, because the number underneath the x squared is the a squared, which means the a is either plus or minus 4. The b squared, which is the number under the y squared, in this case happens to be 4, which means the b is plus or minus 2. And when I go to draw this, I'm going to draw it over here. I'm running out of space, and here's my ellipse. This is the one from over here. My a's are 4 and negative 4. Those are my x-intercepts. My b's are 2 and negative 2. Those are my y-intercepts. And here is what my ellipse should look like. It's wider and shorter. Notice the major axis is along the x-axis. It happens to be 8 units long, while the minor axis, the one along the y-axis, is just 4 units long. Remember, the axis goes from tip to tip rather than from center to tip. So this is what you would look for. You'd look for it crossing the x-axis at 4 and -4 and the y-axis 2 and -2. That's why you have to find the a's and the b's, because they give you the intercepts. Okay, so now let's do that last question. So we're now looking at this question number 4 that looks like 4x squared minus 9y squared equals 36. And we mentioned that this would be a hyperbola because of that minus between the x squared and the y squared terms. Anytime you have a hyperbola, you're going to have a hyperbola anytime you have a x squared and a y squared term in your equation, but one of them will be positive and one of them will be negative. Of course, they both have to be on the same side of the equation before you can make that decision. When the x squared is the positive one and the y squared is negative, then you have your graph just crossing the x-axis and there's no y-intercept. If it would have been the y squared minus the x squared, then it would cross the y-axis but not the x-axis. Again, we would want to put this in standard form, which means this number we divide everything by 36 to get 1 on the other side. And reducing this to 4 with 36 gives me x squared over 9. Remember, the 9 is in the denominator because the larger number is in the denominator. This gives you y squared over 4 equal 1. And that means that your a squared is 9, which means your a is plus or minus 3. These are your x-intercepts. The b squared is 4, but it doesn't help you because there's not going to be any y-intercepts because the y squared is the negative. So when I go to draw this, now this is not a very exact drawing. This is just a sketch. It is possible to do more exact drawings with more, you don't need more information, but some more work that is beyond the scope of this course. We don't have to do it. The hyperbola has 2 branches that look like back-to-back U's. Sometimes the back-to-back U's are sideways, sometimes they're up and down. Depends on whether you have x-intercepts or y-intercepts. In this case, we have one x-intercept at 3, one at -3. So we're going to have sideways back-to-back U's. These two should look exactly the same or mirror images of each other. I know I haven't done a very good job. Sometimes they're narrow U's, sometimes they're wider. Again, that is, how to figure that out is beyond the scope of this course. So you don't have to do that. What you have to look for is to make sure, are you getting x-intercepts or y-intercepts, and are your intercepts at the right points? So that would take care of what you need to, basically what you need to know for conic sections. That was a pretty comprehensive discussion of conic sections. So now let's go on to the next topic I want to review, which is trigonometry. Okay, so first let's just look at an example like this. This is a right triangle. And I'm giving you a picture where this side is the square root of 2 and this side is 4. And I'm asking you to find the third side of that right triangle. I'll just give you a minute to work on that. See if you can do that. While you're at that, I'm going to write a second problem on the board. Okay, so let's work at this problem. There are no letters put here, but let's put in some letters. Let's call this A. Usually that's where I put my A. This one is usually called the B, and this is my C. So this would be my small a because it's across from A. This would be my small b, and this would be my small c. Remember, C always stands for the hypotenuse, which is the one that's across from the right angle. To find the third side of a right triangle, we use the Pythagorean theorem that looks like this. A squared plus b squared equals c squared. And sticking in the numbers, it's the square root of 2 squared plus b squared, because that's the one we don't know. We don't know the b, equals 4 squared. Remember, when we square a radical, when we multiply the square root of 2 by itself, we just remove the radical, we just get plain 2. So this is 2 plus b squared equals, well, here I have to actually work it out. 4 times 4 is 16. I'll bring this 2 to the other side, which will give me b squared equals 14. And that means b is the square root of 14. Usually when we have, let's say, x squared equals a number, we take plus or minus the square root, but we're only taking the positive square root because this stands for the length of the side, so it can't be negative. So my answer for this side is the square root of 14. I hope most of you were able to do that. Okay, I'm going to give you a couple of minutes to work on it together. Okay, I'm going to erase this. And before I do anything, I'm going to remind you of our trigonometric rule or memorization that helps us remember what each of these are. So, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So when I'm told that the sine of A is 2 over 5, I can draw a triangle where the opposite side is 2 and the hypotenuse is 5 because the sine is opposite over hypotenuse. So I'm going to draw myself a right triangle. Again, I'm going to make this my A, B, and C. And remember, in terms of A, this is my opposite side. This is my hypotenuse. And this one over here is the adjacent. So when I pick, for this triangle, I'm going to pick this side to be the 2 and this side to be the 5. Now, the first question that's asked over there is find cosecant A. Now, I just mentioned sine, cosine, and tangent. Those are the primary trigonometric functions. The three other ones, the cosecant, the secant, and something called the cotangent, are what we call the reciprocal functions. They're each the reciprocal of one of the primary ones. The cosecant happens to be the reciprocal of the sine. I remember it's the reciprocal of the sine because the cosecant is starting with a C, starting with that prefix co. So its partner, its reciprocal partner, can't have that prefix co. It has to start with an S. It can't start with a C. So it can't be the cosine, it has to be the sine. Again, the tangent and the cotangent are their old partners. They're easy to remember. So that means that since the sine is 2/5, the cosecant of A, and it doesn't matter what other information I was given, the cosecant of A has to be the reciprocal of the sine, has to be 5/2. So that answered question number A. And notice I didn't have to do any further work on my triangle because it asked for the cosecant. But the next question is the secant. Now, the secant is the reciprocal of the cosine, and the cosine is adjacent over hypotenuse. In order to find the secant, I first want to find the cosine of A. And what I'm missing here is the value of the adjacent side. So therefore, I have to figure out what this third side of the triangle is. And just like we did before, we're going to have to do the Pythagorean theorem. We're again going to have to do a squared, which is 2 squared, plus b squared. We're still missing that b squared. It's the same thing as somehow, equals 5 squared, the hypotenuse. So this is 4 plus b squared equals 25. And that, bringing the 4 to the other side, this gives me that b squared equals 21, which means the b is the square root of 21. So my adjacent side is the square root of 21. What that means in terms of cosine, the cosine is adjacent over hypotenuse. So now I know the adjacent side is square root of 21 over the hypotenuse, which is 5. Now that means that the secant, remember, is the reciprocal of the cosine, is 5 over radical 21. Now usually they don't want you to leave the radical in the denominator. They want the denominator rationalized. So if you come out with a radical in the denominator, just multiply top and bottom by that radical, which will give you 5 radical 21 for the numerator. And when you multiply radical 21 times radical 21, that will just give you the 21. So here's the answer for A. Here's the answer for B. Obviously involved a lot more work. Cosecant is usually when you're asked for the reciprocal function, it usually is not too hard. You just have to flip it. Okay, so now we're up to tangent. And we know the tangent is opposite over adjacent. Well, now we have all 3 parts of our triangle, so I can do that. The opposite is 2. The adjacent is square root of 21. Notice if they had asked me for the cotangent, I would have then flipped this and done the tangent, the square root of 21 over 2. But they didn't. They asked me just for the tangent. But again, I have the same problem where I have a radical in the denominator. So I have to rationalize it by multiplying by radical 21 over radical 21. So my final answer becomes 2 radical 21 over plane 21. And that would be the answer to part C. Again, you would not be given all three of these parts, you would just be given probably one of them. But this would be if they'd asked this, or if they asked that, or if they asked the third. This was a pretty good review of what we learned in terms of trigonometry. Don't forget this SOHCAHTOA. Again, look out for that study guide sheet that I'll be sending it later today. So it will give you, it has all the formulas that you need for the whole term and examples of different questions from throughout the term. So there was one more topic that I'd like to review, and that is the logs, the last thing that we were talking about. Okay, so I'm going to now erase this and put down a few questions on logs, and I'll give you some time to work on them, and then we'll work on them together. Okay, so here are the questions. Number one, the first question I want you to do is just change to exponential form. This is being written in log form. I'd like you to write in exponential form. Okay, the second question is just find the value. The last three are equations. So the last three, I want you to solve each one of these. But I'd like to go through each of them. Okay, let's start with this one, where it says to change this from the logarithmic form to the exponential form. And most of our questions here involve that type of situation where you have to change from the logarithmic form to the exponential form. If you recall, the subscript, that's the base of the number that's going to get the exponent. The word log equals forget about everything in it, we hear it. The number that's on the other side, the log, is actually the exponent. Another word for log is exponent. So this would be 4 to the third, and that's equal to the number that's right next to the word log, which is the 64. So here would be your answer in exponential form. And that's all that this asks you to do. It asks you to switch this from logarithmic form to exponential. Now, that'll give us a hint as to how to solve all these other questions. First of all, this one, it says find the value of log base 6 of 36. Now, I don't know what it is, so I'm going to call it x. There wasn't an x there, but I'm going to call it x. And I'm going to then go from the, again, logarithmic form to the exponential. My base is the subscript, which is 6. My exponent is this number on the other side, which I don't know. Let's call it x. And that is equal to the third number, the number that's right next to the word log, which is 36. In other words, it's saying 6 to what exponent is going to give us 36. Once it's written in exponential form, it again is quite easy to solve because I can see that what exponent should I put on 6 to get 36 is obviously 2. Some of them are not quite as easy as this, but once you have an exponential form, you could then take your calculator and try your different answers. Let's say one answer was a half. You could then do 36 exponent 1/2, and then it will give you an answer. If it gives you 36, good, then you found the right answer. If it doesn't, go on to the next one. So you could very well use your calculator to help you calculate some of these examples. So this is the answer to question number two. So now let's go to question number 3. I'm probably going to have to, in a few minutes, erase some of this, but I think this one we could do without, right here in this space. This is an equation. All of these are log equations. It's saying the log of 2x equals 3. Now what's missing here is the base. Usually we have a number that's a subscript and that's our base. It's not that it was forgotten. Remember, this means it's a common log and the base is understood to be 10. So if I'm going to solve this, I'm going to put it in exponential form. My base is going to be 10. My exponent again is the number on the other side, which is 3. And that'll give us this 2x. I've now changed my question to exponential form. So now I can start solving this. 10 to the third, I know is 10 times 10 times 10 is 1,000 equals 2x. And of course, to figure out what x is, I'll just divide both sides by 2. And that'll give me that my answer is 500. My x has to be equal to 500. So that's the answer to question number A. What about B? Well, again, we have this thing where we have a log equaling a number, but again, we don't have an a base, so we understood it's a common log, the base is 10. So this is 10 to the exponent of 2 will give us 2x minus 5. Again, this is not a terribly difficult equation. 2 squared is 2 times 2 is 100. So the first thing I'll do is add 5 to both sides. So that'll give me 2x, 105 is equal to 2x. And then divide both sides by 2. So that it gives me x equals 105 divided by 2. Usually this answer, which is a improper fraction, is acceptable. If they want it in decimal form, you'll see by the type of answers they give you, just go to your calculator and do 105 divided by 2, and you'll get something like 52.5, which would be the decimal version. Again, usually they want just the fractional version. So now let's look at that last equation. And I'll rewrite over here. Log base 2 of x plus log base 2 of x plus 2 equals 3. All right. Again, this is a log equation. Except the problem here is we have more than one log on the side. All of the equations that we've done with so far, we've dealt with so far, had log on one side and a number on the other side. And now I have two logs on one side equaling a number. So what I have to do is first take this two log system and contract it back to a single log, because my rules all apply to log, just one log, equaling number. So I remember that the logs are exponents, and the rules of logarithmetic are really the rules of exponents, which means that when I have two logs being added, what it really meant was my original numbers were being multiplied. When do you add exponents? When you're multiplying the numbers with the bases. So I'm going to rewrite this as a single log by doing log base 2 of the x times the x plus 2. I multiply these two expressions because their logs were added. If there would have been a minus in between them, instead of multiplying them, I would have divided them. And now I'm at the point where I say a log equaling a number, and I even know the basis of the base is 2. So the 2 is the base. The exponent is a number on the other side, which is this 3. And that's equal to the x times the x plus 2. And now this is a regular algebraic equation that I have to solve. Well, the first thing I'm going to do is figure out what 2 to the third is, which is 2 times 2 times 2, or 8. And here I'm going to remove the parentheses by using the distributive property. That'll give me x squared plus 2x. And I see what I'm left with is a quadratic equation. So I have to get it equal to 0. So I'll bring the 8 to the other side because that's the easier way to go. I always want to leave my x squared positive. So here's my 0 equals x squared plus 2x minus 8. Now, when they give these equations, and it turns out to be a quadratic equation, you can be pretty sure that they're going to give you something that's going to be solvable by factoring, because it's already a longer problem. So this does factor. Let's see what we can factor it into. The x squared goes x and x. The negative 8 means one is positive and one is negative. So we need two numbers that multiply to 8, but when we subtract them, give us 2. Well, obviously, that's 4 and 2. And this is positive, so the larger number, the 4, is going to be the positive. This is going to be the 2 is going to be with a negative. And I'll set each of these equal to 0. So x plus 4 equals 0, will give us x equal to -4, because I'm bringing the 4 to the other side. And x minus 2 equals 0. That'll give me x equals +2 when I bring it to the other side. So I end up with two answers, one being -4 and one being 2. Now, sometimes both answers work, sometimes neither answer works, sometimes one answer works and one doesn't. We have to be careful not to put in an answer that is an extraneous root. And if you recall, with logs, you can only have logs of positive numbers. If you go on your calculator, you press your log button and you put in like -2, for example, it'll give you an error message. It'll tell you you can't do that. If you put in log +4, it'll allow you to do that, but it will not allow you to do the log of a negative number or a 0. So this x being -4 can't be used because it would entail us using a negative number with a log, that the domain of the log is positive only. The 2 works because this is positive and 2 plus 2 is 4 is also positive. So we end up with only one answer. If you would have just stopped here and not thought, and you would have given both answers, and they're going to give you that as an option to a -4, you would get this question wrong. You have to reject the wrong answer, the answer that doesn't work, the answer that is an extraneous root because you're not allowed to use it. So our answer in this case was x equal to 2. So that obviously was a much harder example, but again, this is something you should be able to do. Just one other question from this section. We concentrated on solving logarithmic equations. Let's just do a exponential equation as a reminder of how to solve an exponential equation. So let's say I gave you an equation that looks like this. 6 to the x power equals 180. See, that was my question. So my first question is, see, could I put 180 in base 6? Could I write 180 as 6 to some exponents? Well, let's try it. 6 to the 2 exponent is 36. And 6 to the 3 exponent, I don't know that by heart, but I'm going to take my calculator and use it to figure it out. 6 to the exponent 3 gives me 216. So 6 to the 2 6 to the 2 was 36. 6 to the 3 was 216. And somehow we skipped right over 180. We never got to 180 when we were doing the exponents of 6. So obviously 180 can't be written in base 6. It won't, you will never get 6 to some exponent giving you 180. So the method we use here is the log method. We write the word log right next to each of these expressions. We write log 6 to the x equals log 180. If the two numbers were originally equal, then the logs of those numbers are certainly equal. The reason we do that is because when we have logs, the exponent becomes the coefficient. That's one of the rules of the log properties or the log arithmetic that we learned. We learned that when you multiply numbers, you add their logs. When you divide numbers, you subtract. And when you have an exponent, it becomes a coefficient. It becomes a multiplier because you're really dealing with two exponents. Log 6 is one exponent. X is the other exponent. When you have an exponent with an exponent, you just multiply the two exponents together. So this will become X log 6 equals log 180. And then to figure out what the X is, since this is X times log 6, we'll divide by log 6 to get the X alone. And this has to be done on the calculator. Here's what you do in your calculator. You press your log button. Notice the base I used here was 10. I didn't put any base in because I wanted to be able to use my calculator that has a log base 10. So I press my log button. It'll pop up the word log with a parentheses. You put in the number 180. Close that parentheses. Press your divide button and press your log button again. And again, it'll pop up the word log with a parentheses. You put in the 6 and close that parentheses and press either the equal or the enter, whatever it is. So let's do that. Log 180, close parentheses, divide log 6, close parentheses, enter, and I'm getting something that looks like this, 2.898244402. I'm getting something a long decimal. Usually these numbers are irrational numbers, so they're long decimals. Let's say they asked us to round to 2 decimal places. That means I'd want to stop after the 89, but the next number is an 8. That means I'd have to raise this. So this becomes 2.90. And that would be my answer to 2 decimal places. It doesn't come out exactly because there was no exact answer here. So that's how we solve an exponential equation. I think we're going to stop right here. Don't forget, your final is this Friday from 12 to 2 on Blackboard. It's going to be on your Blackboard account. You will be given, you've done tests on Blackboard. It'll be just like those tests, multiple choice tests, 30 questions. Once you start, you must complete the test in one sitting. If you close it, you are going to be, your test will be submitted. If you run into any difficulty, again, if your internet goes down or something, you must get in touch with me by emailing me immediately so that I could reset it. But as again, I'm not going to be able to reset the test the way you would, where you were up to. It'll just reset it from the beginning. You'll have to start the test all over again. But if you, unless you're like at the last 1 or 2 questions, you might be willing to do that. Of course, I'm going to have to then extend the time for you. So you better let me know. You better do this on time. So because I will be there for the time that the exam is supposed to be there. If you start the test too late, you're going to run out of time because I'm going to set it up. I will give you some leeway on the sides. I may open it up before 12. I may, so that you can get started before 12. I may give you until 3 because if you happen to start late or you have a problem, there might be a little bit of time on the other end. But beyond that, I'm not going to be available. And if you have a problem, you're going to be stuck. So make sure if you have any problems, you've got to let me know so that I can, if you can't take it at this time, then we have to set up an alternate date. And I want to do an alternate date where all the people that are running into conflicts can take it at the same time so that I can be there for them. All right. I'm wishing you all best of luck. I opened up all the Delta math assignments and all the tests also on Blackboard. If you have not completed them, I've given you until Thursday evening. By then, I'm closing the books because on Friday, your test is coming up. So the only thing that you'll be able to do beyond Thursday will be work on the practice final. The practice final, I think, is available until Friday. But if you have other work that has to be completed, make sure it's completed by Thursday evening. I've extended this and extended this. I really want to see you get good marks, but I can only do what I'm capable of doing. I wish you all the best of luck. And I wish I could have met some of you in person. It was a trying semester. I hope this worked for you. I hope you do well on your final and you hope you get good grades on all your finals and all your classes. I know it involved a lot of extra input and effort on your part to get it done this way. So I'm wishing you all the best of luck. Unless somebody has a question, I'm going to end right now. Bye. Bye, Shireen. Have a great holiday. Thank you so much for always being there for us. You too, Bernardo. Okay. Hope to see you, Shireen, next term. Great. I'm so glad to hear that. Okay, bye, bye everybody.